Ever felt your car shudder when you slam on the brakes, or heard a weird grinding noise? Or maybe you've tried to accelerate on a slippery road and felt the wheels just spin. That's not your car braking. That's actually your car saving you. Today, we're rediving deep into two amazing pieces of automotive tech that work tirelessly to keep you safe. The anti-lock braking system, or ABS, and traction control. Let's start with ABS. Imagine you're driving, and suddenly a deer jumps out in front of you. Your natural instinct is to stomp on the brake pedal as hard as you can. Without ABS, this would lock up your wheels. Locked wheels don't just stop rolling, they start skidding. And when you're skidding, you have zero steering control. Your car just slides forward in whatever direction it was already going, straight towards that deer. This is where ABS becomes your hero. It has sensors on each wheel that monitor how fast they're spinning. The moment a sensor detects that a wheel is about to lock up and skid, the ABS computer kicks in. It rapidly pumps the brakes for you, much faster than any human could, maybe 15 times a second. This pulsing action is what you feel as a shudder through the brake pedal. It keeps the wheels rotating just enough so you can still steer the car around the obstacle while braking hard. So, if you ever feel that pulsing, don't lift your foot. Keep firm pressure on the brake and steer to safety. That's the system doing its job perfectly. Now, let's talk about its close cousin, traction control, sometimes called TCS or ASR. While ABS helps you when you're stopping, traction control helps you when you're starting or accelerating. It uses the very same wheel speed sensors as the ABS. Its job is to detect if one of your drive wheels is spinning faster than the others. This usually happens on slippery surfaces like ice, snow, wet leaves, or even gravel. When the wheel spins freely, it loses grip or traction. This means all the engine's power is going to that one spinning wheel, and you're not actually moving forward. It's like running in place. When traction control detects this wheel spin, it jumps into action in one of two ways, or sometimes both. First, it can apply the brake to just that one spinning wheel. This slows it down, forcing the power to be redirected to the other drive wheel that still has grip, pushing you forward. Second, on more advanced systems, it can communicate with the engine's computer and say, "Hey, we're spinning out here. Cut the power a bit." The engine then reduces its output just enough for the wheels to regain traction. You might see a little light flash on your dashboard, the one with a car and squiggly lines behind it. That's your traction control, telling you it just saved you from a spin out. So, how do these two systems work together? They form the foundation of something even more advanced. Electronic Stability Control, or ESC. ESC uses the same sensors and hardware but with a much smarter brain. It can brake individual wheels and manage engine power, not just to prevent skids during braking or accelerating, but also during cornering. If you take a corner too fast and the car starts to understeer or oversteer, ESC can brake the correct wheel to tuck the car back into line. It's like a guardian angel constantly monitoring your car's stability. These systems are incredible feats of engineering. They're constantly working in the background, making thousands of calculations every second to keep your tires connected to the road. They're not magic, of course. They can't defy the laws of physics, but they dramatically expand the margin of safety, giving you more control when you need it most. They turn a potentially catastrophic loss of control into a manageable situation. So next time you feel that pulse in the pedal or see that little light flash on your dash, give a little nod of thanks to the brilliant engineers who designed these systems. They're the unsung heroes of modern car safety. Thanks for tuning into Code. If you found this helpful, hit that like button, subscribe for more deep dives into car tech, and let us know in the comments what system you'd like us to break down next. Drive safe out there.